Okay, so we're going to start off today with a little bit of notes. We're doing section 8.2. We don't have a ton, and then we're going to spend the rest of the hour on can figure it. And I actually noticed some of you already had done all the can figure it proofs already, so you're ahead of the game. We are still learning more about parallelograms. And the question is if we know it's a parallelogram, what conclusions can we make? That's where we're headed today. Well, you're probably thinking, didn't we just do that last Tuesday? Well, kind of. Last Tuesday, we said if these conditions are true, then it's a parallelogram. Today, we're switching it around and we're saying if it's a parallelogram, then the following conditions have to be true. I like this section because it gives us an opportunity to go back over everything from last Tuesday's lesson. All right, so 8.2, I can use properties of parallelograms to find angle and side measures. That's where we're looking at today. Right, so we're looking at parallelogram theorems, flipping it around from what we did Monday, Tuesday. So we're going to start with the hypothesis of if a quadrilateral is a parallelogram. That's important to note. We know it's a parallelogram. So then what has to be true? Well, the definition has to be true. So if a four-sided shape is a parallelogram, then by the definition, its opposite sides are parallel. We use this one quite often in proofs. Right? If we can prove opposite sides are parallel, then it's a parallelogram. So if we know it's a parallelogram, then opposite sides have to be parallel. And I'll just point this out, I don't care about the theorem number. So you don't even really have to write theorem 8.3. That is specific to only our textbook. So all you have to know is the reason right here. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So we know that their opposite sides are parallel, and we know opposite sides are congruent. If a quadrilateral is a parallelogram, then we know that opposite angles are congruent. If a quadrilateral is a parallelogram, then we know that consecutive angles are supplementary. And I will give you time to write all this down. I'm just going to kind of go through it here quick. If a quadrilateral is a parallelogram, then we know that its diagonals bisect each other. So those are the four theorems that we have in this section. But we've already learned that from Monday, Tuesday. And then the last piece is just a combination of the definition and theorem 3.8. So if a quadrilateral is a parallelogram, then one pair of sides must be both congruent and parallel. This one is very helpful when doing proofs. Okay, so let's just go through these again, but then add the picture for each piece. So if a quadrilateral is a parallelogram, then by the definition, our conclusion is opposite sides must be parallel. So if you see that it is a parallelogram, you know this has to be true. We actually ended up proving a lot of these on Monday, Tuesday, so we're not going to go through and justify them, but that has to be true. Also, if it is a parallelogram, then opposite sides are congruent. So I know that sides that are opposite of each other have to be the same length. Opposite angles have to be congruent. So I also know that the angles across from one another are congruent. Okay. And then the one that a lot of students kind of forget about is the consecutive angles are supplementary. which means if I talk about consecutive angles, the word consecutive means kind of right in an order. So like here, if I have angle X and angle Y, and if I know for sure that X plus Y, well, if I know it's a parallelogram, then I know for sure that X plus Y equals 180. But look at the theorem right before it. If opposite angles are congruent, that also means that this angle here has to be X. So these two consecutive angles have to fit this relationship as well. So X plus Y has to equal 180 here, and X plus Y has to equal 180 here. And then same justification, opposite angles are congruent here. So this has to be Y. And that means X plus Y here also have to equal 180, and this X plus Y have to equal 180. So all consecutive angle pairs will always equal 180 in a parallelogram. I think I'm going to make this parallelogram a little bigger. So Theorem 8.6 says the diagonals bisect each other. And this is the one that a lot of students end up misinterpreting. So notice this, let's do it a different color. The red diagonal is not anywhere near the same length as the blue diagonal. So the diagonals are not the same length. But if I told you that the red diagonal bisected the blue one, that means the red diagonal bisects the blue, so it's the blue that is being cut in half. So that's the first kind of statement. And then if I told you the blue diagonal bisected the red one is the one that's being cut in half. So if it's a parallelogram, you also know that the diagonals bisect each other, so they're cut in half. And then probably my favorite one, which isn't officially a theorem in the book, but it's a combined definition in a theorem, is if it's a parallelogram, and again, this one right here, I would put a star next to it because it's one of the most helpful ones we can do with doing a proof. Because all we have to do is prove that one side is congruent and parallel. So notice, I don't need to know anything about the other two sides. I just need to know that one side is both parallel and congruent to the other side. Okay, let's go over this and I'm going to take a look. And I want to kind of show my thought process in this. So when I see a problem like this, I see the word parallelogram. Right? So I'm thinking all of the things we just talked about have to be true, but which one of those specifically relate to this problem? One angle is 4 times the measure of another. So now we're talking about angles. So I'm thinking, if I go back really quick, I'm thinking, okay, I have theorem 8.4, opposite angles are congruent. All right, that could help. Or I have consecutive angles are supplementary. I only have 2 theorems that really based off of angles, and which one will help me solve this problem. Now, they both can work, and I'll show you how both of them we could use either one. But this is how my brain works. Okay? One angle is 4 times the measure of another angle. Do we know what the other angle is? No. And when we don't know what something is called in math, we can use a variable. Let's call it x. So if the angle we don't know is x, and the other angle is 4 times that, then all of a sudden I know the relationships of the angles. So let's say I don't know the angle here, and I'm picking this one because it's the smaller one. I'm going to call this one x, and then the other angle that I don't know has to be 4 times that. Now you could stop right here because the theorem that I would use is our conclusion is because it's a parallelogram, consecutive angles are supplementary. So that means these two angles, because they're next to each other, have to add up to 180. And there's the algebra problem. So from there, we have to find all four angles. So we can add our x's, and we can divide. We get 36. So that's x, but we're not done, right? Because we want to find all the angles. So if I go back in and plug in, this is 36 degrees. 36 times 4 gives me 144. So those are the two angles, but then if we want to find all four, I actually have to know that opposite angles are congruent as well. So this is 36, and opposite of this is 144. That's one way to do this problem. It is not the only way. If you really wanted to, you could have wrote this as x here, and this is 4x, and you could have taken what we learned from 8.1 and known that all interior angles for any quadrilateral will always add up to 360. So you could have done this work as well. It's basically doing twice as much work as this, because we get 360 equals 10x, and notice if you divide by 10, you still get 300 or 36. So either way, it works out. All right. Any questions? Why don't you guys try this problem and actually, oops, sorry. It's up to you if you want to write this. You can write it or you don't need to. But I want you to solve for x, and then I want you to send me a private chat with your answer for x based off of the figure given as a parallelogram. Solve for x. So tell me your answer when you're done, and we'll give you a couple minutes on this one. How do we think about this? Well, first thing is it is a parallelogram, and it shows the diagonals. So I can conclude, because it's a parallelogram, that the diagonals will bisect each other. So I know I only have one pair of diagonal, which is the blue one. Well, if the diagonals bisect, then that means the expression of 2x plus 5 has to be the exact same length as 3x minus 1. So there's the algebra problem. And then it's moving the x's over to one side. You don't need to show all this work, but I get 1x on this side. And then if I move the 1 over to this side, I end up with 1x equals 6. If I divide by 1, I get x equals 6. Okay? So that is kind of the approach we're going to take. Now, if I was doing this on a test, that's the answer. They said solve for x, but what I would do is I'd take this answer and check. Let's see. 2 times 6 is 12. 12 plus 15 is 17. So this length from here to the center is 17. And then 3 times 6 is 18 minus 1 is also 17. So because those lengths are the same, confirms that my answer is correct. Okay. So here's what we got. Yeah, a couple people sent the 17 as an answer. It's okay. Like I said, I'm not checking to see that you did it right or wrong. I'm checking just to see that you're engaged in class. And then when we go over it, if you did get it wrong, it confirms why. All right, so what we're going to do is we're going to do can figure it, but we're going to do it with properties of parallelograms. And I'm going to show you two of them that as a refresher. So I just want you to watch. And it's a little tricky, especially this first one that we're going to go over. But I want to give you some hints. Now, these hints aren't always the same hints every time. It's just a general approach. So it says, prove, if we're doing proofs on Can Figure It, prove triangles are congruent. If you can do that, which most of the times you can, then you can use Cpctc to make anything true about those triangles that you just proved were congruent, like sides or angles. And then you can use that new Cpctc information to follow any of the proofs for parallelograms. Okay, so let me start with this. We're going to do properties of parallelograms 3. So I'm going to just go to, instead of trying to find it, I'm going to go to quadrilaterals. And then for me, I'm going to do all activities because you guys don't want to, I don't want to do any of the ones that you have to do. And then I'm going to do properties of parallelograms 3. This one right here. You can see I already did it, so I'm going to actually start over. All right, definitely watch this one. If you happen to have your cell phone in hand right now, put it down. Okay, if you have anything distracting near you, try to eliminate that. Please pay attention here. This is tricky, and I want to show you how friendly it can be if you know the one trick. All right, so our goal, maybe I can make this a little bigger. That should be better. Okay, our goal is to prove that these two angles, the blue angles, angle F and angle D, are congruent. Now notice they're from two different shapes. Okay, but what do we know? I know that the big shape ABCD, you can see it highlights in purple, is a parallelogram. So that means all of those things we just took notes on have to be true. And then I know that EBGF is also a parallelogram, the small little yellow one. So they're both parallelograms, and my goal is to prove that the angle in the small parallelogram F is equal to the angle in the big parallelogram D. Well, my only connection between the big triangle or the big parallelogram and the small one regarding angles is angle B. All right, so I know that because opposite angles are congruent in a parallelogram, angle B and angle F have to be congruent. And the same thing is true, angle B and angle D have to be congruent. So I know all of that before I even start because these are parallelograms. So here's what I'm going to do. I'm going to start with the first one, the big triangle, or big parallelogram. And I'm going to say that I've got congruent angles. We'll go to congruent angles, and I'm going to say that angle B is congruent to angle D. Right? And now my claim, why do I know that? I have to go off of my given information. I know that because ABCD is a parallelogram. So I'm going to search for the parallelogram ones, and there's not a lot of them, right? There's actually technically only one that's provided right here. In a parallelogram, opposite angles are congruent. So I'll click on that, and then it says, which one is your parallelogram? Well, that's given. So I'm just going to snap ABCD into that place. Because it's a parallelogram, these two angles are congruent because opposite angles are congruent. So there's my claim. You can see angle B and D highlight. Now I'm going to go to a new claim, and I'm going to use the bottom given to show that B and F are congruent. So we're going to go to angles. I'm going to say angle B is congruent to angle F. And why do I know that? Because I have another parallelogram. So I'm going to find the one that looks like a parallelogram. I'm going to read the statement. In the parallelogram, opposite angles are congruent. That's what I'm trying to prove. And I'll go to EBGF is the parallelogram. And I'll click submit. Okay, now look at it. I just proved that F is congruent to B and D is congruent to B. So if F is congruent to the same thing that D is congruent, don't we know that F and D are congruent, which is what the statement is? So I'm going to go to the unjustified claim. And then here's the tricky part. We've talked about it, but we haven't used it often. But when two things are equal to the same thing, that's called the transitive property. And here's my hint. See the three angles? If we read this, it says the transitive is if two angles are each congruent to a third angle, then they are congruent to each other. So that's the option I'm going to pick. And it says, okay, well, angle F was congruent to what? Angle F was congruent to angle B, and angle D, CDA, was also congruent to angle B. So I'm going to put in the same angle here, and that proves that if F is congruent to B and D is congruent to B, then F and D are congruent. So I'll submit, and we're done. That's an example of using transitive property. Okay? I believe the very first proof that you have to do is one just like this. So it's really quick, transitive property. Okay, so that one, notice we didn't have to prove the triangles were congruent. We just used properties because we already knew that they were parallelograms. Okay, but what about this one? We're going to do Cpctc in a parallelogram 3. Okay, so I got to scroll till I find Cpctc in a parallelogram 3. And you can see this one, I did this one already, but it's much longer. So this one, I just started over. Look at the directions. Prove it's a parallelogram. So now I'm thinking if you're proving something's a parallelogram, you're most likely going to have to prove that triangles are congruent, and then use Cpctc, and then use that new information for any way to prove it's a parallelogram. So let's look at what's given first. And I'm going to do this by highlighting. So if you look at my shape, the two purple lines, EA and FC, are congruent. That's given. And then the yellow lines are congruent as well. And then they actually say that you can see this line and this line are perpendicular. Now, the one thing I don't like is they already put the 90-degree angle boxes in there, but we have to prove that those are right triangles. So here's my goal. I'm going to prove this triangle is congruent to this one by side, angle, side. Well, I already have the two sides as givens, but I don't officially have a statement that says this angle is congruent to this angle. But since they're both perpendicular, I can say that they're right angles, and then the right angles are congruent. So I'm going to do that first. I'm going to go to angles, and I want to prove that I have a right angle. And which one? It's angle DEA. Well, how do I know it's a right angle? Because they told me it was perpendicular. So I'm going to find perpendicular lines meet at a right angle. And then I have to pick the correct one. Now notice, if I pick the bottom one, that proves that this one is a right angle. I need the one that highlights this angle. So snap that into place. That shows it's a right angle. So now I know that this is a right angle, and I got to do the same thing over here. So angle, right angle, angle BFC. And why do I know that? Because the given perpendicular. And then I have to pick the bottom gift or given one that says that FB is perpendicular to AC. Okay, now a lot of students would want to prove that these are right triangles, but we're not using HL, we're using side, angle, side. So I don't need to show that this is a right triangle. I just need to show that they're right angles, because if they're both right angles, then I can say that the angles are congruent. So I can say that this angle is congruent to this angle. And why do I know that? Because all right angles are congruent. That's the one with the 90-degree angle boxes. Since we proved there are right angles up here, I can state that they're congruent. And notice, now I have the congruent statement. A lot of students are going to try to prove these triangles are congruent before they say that they're congruent. But now, so I did all of this work to prove these triangles are congruent. So we'll go to triangles, congruent triangles, and I want ADE congruent to BFC. Well, how do I know that they're congruent? Because side, angle, side. So that was the first one, side, angle, side. And then we already have everything right here. I've got the side. I proved the angles. Ooh, this is interesting. I'll show you what happens in a second. So notice I did side, angle, side here, and it says question marks. What happens is the triangle that I wrote down first. Oh, no, sorry. I put the wrong triangle right here. I didn't click on the right one. So I'm going to have to do that one later. Actually, I'm going to get rid of that one and start it over again because I clicked the wrong triangle. I thought I clicked the right one. I want ADE. That's the one I want. And BCF. So just double check that you're actually doing the right triangles. And then we're going to do side, angle, side. So now let's see. It allows me to put in side, angle, side, and triangles are congruent. Cool. All right, so what did I do? I proved the triangles are congruent. I basically did the red step. Then I'm going to use Cpctc to try to prove any new information that'll make this a parallelogram. Well, remember how I said if you can show one pair is parallel and congruent, one pair of sides, that's a very fast way of proving that it's a parallelogram. And that's the one I'm going to do. I'm going to try to prove that I have one pair of sides that are parallel and congruent. So I now know that these triangles are congruent. So I can quickly use Cpctc to prove that the hypotenuses of each side are congruent. So I'm going to go congruent sides, AD congruent to BC. And my reason, how do I know that? Because Cpctc. Corresponding parts congruent, triangles are congruent, and then click on the congruent side. So now I just showed I have one pair of sides congruent. Now notice, I don't know anything about this other triangle, and I could find a way to prove that this triangle is congruent to this one, but it would be a lot of extra work. It's going to be easier to prove that this side is parallel to this side. And the way I'm going to do that is I'm going to use the Z. I can prove that this angle here is congruent to this angle here. That'll make a Z, which means these two sides are parallel. Okay, so I'm going to do congruent angles, and I want angle CAD and ACB. I want those to be congruent because I have congruent triangles. So Cpctc again. All right, now notice those angles are congruent because they're of congruent triangles. So then I can state I have alternate interior angles, which means the lines are parallel. So I have to find one that says parallel. And I want to show that AD is parallel to BC. I'll click claim. And how do I know that they were parallel? Because we had the Z, alternate interior angles converse. And then which angles were those? Those were the ones I just proved before. And then I have to state what is the transversal, and that's the long length AC. And that'll prove that my lines are parallel. So I have a pair of sides that are both congruent and parallel, and that is enough for me to prove that a shape is a parallelogram. So look at the options here. I could have proved both sides were parallel. I could have proved both pairs of sides were congruent, but that would be much more work. I could try to prove that the angles are congruent, but that would be a lot of work. Or I could use this one right here. If one pair of sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. And then I just have to state, well, which sides are congruent? Those are the sides that I stated right here in blue. And which sides are parallel? It's the same sides, so it automatically snaps in. We're done. Okay, now this is a lot. So just a quick recap. What did I do with most of this? Most of it was proving the triangles are congruent. Then I used Cpctc to prove the other two statements. And then I used those statements to find the parallel lines. And once I had what I needed, I could prove its parallelogram. Okay? Some of these proofs are friendlier than others. So here's what we got. Your homework tonight is to do 8 parallelogram proofs. These hints aren't always the case. Okay? And these are the 8 proofs that you have to do. I'm going to tell you a hint right away on the first one. You will have to use the transitive property the way I just showed you. All the other ones, you're going to kind of have to work through on your own.